Hello, my name is Pieter ter Doest, and I would like to give a presentation about my paper, the Delta Normal AGI. What is it about? Well, the Delta Normal AGI refers to Ben Goertzel's paper, The General Theory of General Intelligence, and that paper can be found on Archive. Possible use cases for the AGI are, for instance, webshop content generation and, for instance, care home social companion software. The AGI makes use of certain basic principles, as can be found in this list. The starting point of the Delta Normal AGI is that it's all about problem solving in dialogues. And that is why the AGI is built around PSDs, problem solving dialogues. Next to the PSDs, quarks are also essential. There's another important principle for the AGI, which is the evolution principle. So we have population, we have signal input, operation, and evaluation, and this goes in a loop. And this can also be done in a fractal or recursive manner. The AGI makes use of two basic important algorithms. The first I call lookup-add, and the second switch router. So if we take a look at the lookup-add algorithm, it looks up in a record table whether an entry exists. If it doesn't exist, it will add the entry to the same table. The similarity check is done based on quarks. So each element has a number of quarks associated with it, and then the algorithm will look whether there's overlap between the two quark populations. The second algorithm is based on the patch paradigm, which is that the total AGI has a certain amount of knowledge, and this can be divided up in patches. So each patch stands for a smaller amount of information, and the total of these patches gives again the total knowledge of the AGI. So how does the AGI obtain its information? Well, for this I make use of the TCAL mechanism from Monash University in Australia. TCAL stands for topic, explanation, evidence, comments, and link. So the AGI will ask, well, what is the topic? What is the goal? What is the evidence for the information I have or I get? And what are the comments on this information? And you can translate these steps to the different use cases. So for instance, for a care home, the AGI will ask the user, what is the topic? Or it will try to assess what the topic is. What is the goal? What is the evidence for the information I give to you or I get? And what comments can I deliver on this information? Then if we take a closer look at the PSD, the PSD actually is a COFO as defined by Goertzel. So if we have an element, this element is actually determined by different factors. So for instance, emotion, or the different TCAL components, or the drivers, or the previous element. And the quarks, of course, underlie all these elements. So then the next element is formed, and the total of the elements form a sentence. Another way of looking at this is that the PhD actually is a triangle form, and the lowest layer is the machine learning or sub-symbolic layer, and the higher we get, the closer to the target, the higher the information content level gets, and also the information gets more and more symbolic. And this total is of course then a layered model. The PSD is a fractal, so a total PSD can be made up of smaller PSDs, and the Delta Normal AGI is all about selecting and optimizing the best PSDs. So PSD stands for problem solving dialogue, and we can depict it as follows. So we have a delta axis in which the delta is the discrepancy from the target or from the normal information, and we have in this axis we have progress or time, if you will. And then in time the target gets reached, and the target has the highest information content level, ICL. You can compare this to the definition of Pai Wang, in which he says that intelligence is based on how to work with insufficient knowledge and resources. So this is also limited, the delta is limited, and the amount of time is limited. And in this time, the information has to be built up. So the PSDs can be made up of different smaller PSDs, and for instance, to match, to balance, find, generate, control, all these different PSDs can be used as a sort of a blocks to make one bigger PSD. So now I would like to show you some of the code I've written. We give an input, for instance, hello, and then we get an output and it recognizes a class. Or if we input chair, it will recognize the quark support. And if we then put in table, it also has the quark support, so there is an overlap in the quarks. If I would now say I feel bad, then it will recognize it as a problem, so I can choose the different sub-PSDs to solve my problem. Well, that is about it. So thank you for listening to my presentation, and if you have any questions, please let me know.